Hello students, in this video we are going to learn about the consumer choices involving risk and uncertainty. In conventional consumer equilibrium analysis, the variables such as price, income, etc. are assumed to be constant, and the consumption pattern was dealing with certainty. Or we can say that suppose if a consumer is consuming a product, he expects certain amount of utility, and it is almost sure that he can derive that amount of utility from consumption. Suppose if a consumer is taking food, it is expected that the food has the power to satisfy the needs of the consumer. Similarly, water has the power to satisfy the need of thirst of the consumer. Therefore, in conventional analysis, the dealing of the consumer was with certain situations, but in the real world, the condition is not similar as envisaged by the conventional analysis. In the real world, there are various situations by which a consumer is supposed to deal uncertainty. The values of our asset may go up or go down. The income of the consumer may change. The price of the product may increase or decrease even after purchase. And all these are uncertain situations by which a consumer is supposed to deal. That is, in the real world, a consumer is dealing situations with risk or uncertainty. Therefore, a consumer normally need to compare the riskiness of alternative choices. A consumer need to decide how much risk is to be taken, or what is the level of desirable risk. What are the possibilities of eliminating risk, or how the risk can be reduced. While reducing risk, what are the other elements to consider? These are the major questions faced by a consumer in the world of uncertainty. And automatically, the behavior of the consumer is becoming unpredictable. Therefore, in this chapter, we are going to deal the situations of risk and uncertainty, and how a consumer is going to deal with risk and uncertainty, and what are the elements that influences the measurement of risk and uncertainty. First of all, we are going to distinguish between the term risk and uncertainty. The term risk and uncertainty are used interchangeably because these terms connote same meaning. The first distinction between risk and uncertainty was done by Frank Knight in the year 1921. In 1921, he published an article. The name of the article was Risk, Uncertainty and Profit. F. Knight distinguished the term uncertainty and risk in a more clear way, in a systematic way. According to Knight, uncertainty is a situation in which many outcomes are possible, but the likelihood of each is unknown. That is, there are different outcomes, but what is the possibility of occurring each outcome is unknown to the participant. Such a situation can be treated as an uncertain situation. But risk is different from uncertain situation or uncertainty. Risk is the term to refer a situation in which we can list all possible outcomes and how the likelihood of each outcome is occurring. There are different outcomes and it is possible to assess the likelihood of each and every outcomes. Therefore, risk can be measured but uncertainty cannot be measured. Or we can say that risk is a condition, is a situation of measuring uncertainty. The simple way of understanding risk and uncertainty is risk is the known unknown, but uncertainty is the unknown unknown. That is, in case of risk, we know the possibilities, but in case of uncertainty, it is not possible to predict the possibilities or measure the possibilities. In this chapter, we are dealing risk because we are measuring the element of uncertainty and therefore we are converting the uncertainty element into risk. Suppose, for example, a company is going to make a new investment. Normally, this new investment is being made in a new area. We know that there are two possible outcomes. This investment may become success or it may be a failure. If the company is succeeding in its investment activities, they can earn a profit of rupees 100 crores. But if they fail in their investment activity and they can't succeed, then they will have to suffer a loss of rupees 75 crores. That is, the two possible outcomes are profit of 100 or loss of 75 crores. This situation is a risky situation. Here we know the possible outcomes and we know the loss or gain associated with these outcomes. Therefore, one of the most important determinant of risk is probability. On the basis of this probability, a consumer can assess the expected value. Besides, in some situations, the expected value of an event may be same, but the risk element may be different. In such a situation, one more element, the variability, also affects the element of risk. Thus, it is necessary to explain the terms probability, expected value, and variability one by one. First of all, we are moving to describe and explain the concept of probability. Probability can be defined as the likelihood that a given outcome will occur. In other words, it is the possibility of occurring an event. In our previous example of investment, if the investment is successful, the company can earn 100 crore profit, and if they are suffering loss, they will have to suffer a loss of 75 crores. Suppose let us assume that the probability of getting this investment successful is 1 by 4, and automatically the probability of failure will be 3 by 4. Which means that there are only two possibilities. Either the investment may become successful or unsuccessful. If the investment is successful, they can earn a profit of 100 crores, and the probability of the event becoming successful is 1 by 4, and the probability of the event becoming unsuccessful is 3 by 4. Here the thing is that the possibility of all possible outcome is added, then it will be 1 or it will be 100%. If we add the probabilities, that is 1 by 4 plus 3 by 4 is equal to 1, or we can say that probability of winning is 25% and the probability of losing is 75%, and automatically it comes 100%. Suppose if there are 3 outcomes, the probability of all the three outcomes added together, we will get 1. The interpretation that we are given to probability may be objective interpretation or may be subjective interpretation. This classification is normally depends upon the nature of the uncertain event. The objective probability based on the frequency of occurring the event. For example, suppose a company made an investment 100 times and they were successful in 25 times. Then we can say that the success rate is 1 by 4. And automatically its failure rate will be 3 by 4. Here we are depending past experiences and we have relied on the probability or frequency of similar experiences. And in such a case, we can have the objective probability. Suppose if there are no such previous experiences, we will have to depend on subjective probability. In subjective probability, we are depending the perception of different individuals or feeling of an individual. In subjective probability, we are depending the judgment of different individuals or experience of different individuals. Suppose if we are considering subjective probability, the perception of individuals may be different and automatically there will be different probability levels or different measures of probability. If the probabilities are different, the choices also will be different. That is, the choices of different individuals will be different. We know that the ability of a person to measure or to assess the information gained will be different, and automatically either different information or different abilities to process the same information may lead to different levels of subjective probabilities among different individuals. We here just need to understand that there are different interpretations, that is objective interpretation and subjective interpretation of probabilities. Regardless of the interpretation of probability, we are using other two elements, that is variability and expected value, to measure the amount of risk and to compare the risky choices. As the next step, we are going to measure the expected value. The term expected value can be defined as the probability or weighted average of the payoffs associated with all possible outcomes. Once again, the expected value associated with an uncertain situation is a weighted average of the payoffs or values associated with all possible outcomes. In measuring expected value, we are considering the probabilities of each outcome as their weights. A payoff is a value associated with a possible outcome. Now let us take our previous example. In our previous example, if the investment is successful, then the profit of the company is 100 crores and its possibility is 1 by 4 and automatically its probability of winning is 0.25. Here the payoff is 100 crores and probability is 0.25. The company may suffer loss of 75 crores if the investment is unsuccessful, and the probability of unsuccessful investment is 3 by 4 and automatically its probability is 0.75. Here the payoff associated with this loss is this 75 crores and the probability is 0.75. From these payoffs, we can measure the expected value, and there is a formula to measure expected value. That is, expected value is equal to probability of winning into winning amount plus probability of losing or failure into failure amount. This is the equation for measuring expected value, and here in our example the probability of winning is 0.25 into probability of winning amount, that is 100 crores, plus probability of losing is 0.75 into losing amount is 75 crores. This is a negative value because we are suffering loss, and therefore we have plotted minus 75, and it will be equal to 25 plus negative 52.65, that is equal to 31.25 minus 31.25. Here expected value of our previous example is minus 31.25. Let us take another example of measuring expected value with more than two outcomes. Suppose this individual A is going to buy the shares of a particular company. There are different possibilities that share price may increase. Suppose if the company is performing well, the individual is going to have outcome X1 where he is going to gain 500 rupees, and the probability of winning this X1 is 0.3. If the company is not performing up to this level but performing at a satisfactory level, then the investor can earn a profit of 300. Therefore outcome X2 is 300, or payoff associated with X2 is 300, and probability of this outcome is 0.5. Similarly, if the company is performing in worst manner, the outcome can be X3, and the investor can earn a profit of 100 only, and the probability of this is equal to 0.2. Here it is clear that PR1 is 0.3 and PR2 is 0.5 and PR3 is 0.2. All these added, we will get value is equal to 1. Here we can calculate expected value as 0.3 into 500, that is the probability of payoff matrix, payoff amount associated with the first X1 into the probability plus probability of second event 0.5 into payoff 300 plus 0.2 into 100, that is equal to 150 plus 150 plus 20, that is equal to 320. Here the expected value is 320 rupees. Suppose if we changing the X3 outcome, the payoff associated with X3, that is the investor is going to suffer a loss of 100 if X3 is the outcome, then the value will be minus 100, and if all the probabilities remains the same, the expected value will be 0.3 into 500 plus 0.5 into 300 plus 0.2 into minus 100, that is equal to 150 plus 150 plus minus 20. Here the amount will be equal to 280. That is, when there is change in payoffs, that is payoff has been changed from plus 100 to minus 100, the expected value also has been changed. Therefore, we can generalize the equation of measuring expected value. Suppose if there are n possible outcomes, then expected value is equal to probability of 1 into x1 plus probability of 2 into x2 plus etc 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 probability of n into xn. where PR denotes the probabilities of events 1, 2, 3, etc., etc. up to n, and x1 or xn denotes the payoffs of 1, 2, 3, 4, etc., etc. up to n. This is the general equation of identifying expected value of different events. We will be using this equation in measuring NM index, Newman-Morgenstern index. In the next part of the video, we will be explaining the concept of variability and how it affects the measurement of risk.